Okay, so this is the introduction video for formation of ions worksheet. And the first three questions we're just going to go through verbally here. So if you need to pause the video to write down these answers or type these answers, you go for it. Okay. So the first question says, what are valence electrons? So hopefully we remember by now that valence electrons are the highest energy electrons in an atom. So if you are looking at an electron configuration, you can determine that by looking at the large numbers. Those are your energy levels. Find your highest energy level. Sometimes it appears as both an S and a P, so you have two sections of level 4 or level 5, okay, or whatever the level is. You're going to add together the electrons that are in that level. So if you only have one level 4, then just however many electrons are in that level 4. But if you have a 4S and a 4P, you have to add those together, for example, okay? So the maximum number of valence electrons you can have is 8. But just as for number 1, all you have to write is the highest energy level electrons in an atom, okay? All right, 2, what is the octet rule? So now we're starting to look at element stability, and the octet rule is elements are stable when they have noble gas configuration. Elements are stable with noble gas configuration. Now for most elements, that's going to mean 8 valence electrons. Some of them are going to be stable with 2 because helium is a noble gas and helium has 2. But basically it's a full valence layer of the atom. And of course there are exceptions and we will talk about those. Number 3, if an atom doesn't have an octet, what are some options that can give it an octet? Okay. Well, on this worksheet we're going to be working with forming ions. And the way that ions are formed is by gaining electrons or losing electrons. When something is very close to having 8, it has 5 or 6 or 7, it's more than halfway there. It's going to gain the difference to get to 8. So it'll gain 3 or 2 or 1 to fill up that outer layer. If it is very far away from 8, okay, we're talking about 1 electron in its valence shell, or 2 or 3. 1, 2, or 3. It's going to lose all of those valence electrons, which gets rid of that layer and gets to a full layer underneath. And we're going to show you examples of each of these in this activity. Okay? Another option to get an octet is sharing electrons, and that's chapter 8. So we don't need to worry about that yet. We're going to go with just giving and taking for this activity. Now, if you're paying really close attention, you might notice that I didn't mention if it has 4 valence electrons, what it will do. Well, those are going to share. So we're going to just not have any on this worksheet that end up with 4 valence electrons. So if you get 4 valence electrons on this worksheet, it means something went wrong. Check your work, fix it, and move on from there. Okay? Now, bottom part of this worksheet, we're going to do 2 examples as a class, arsenic and barium. There are 5 things that you need to do for each element. We're going to do those for arsenic and barium right now. So number 1, write the full and abbreviated electron configurations for arsenic and barium, okay? Now, if you haven't learned how to do this yet, this isn't going away. You need to come in and talk to your teacher or Zoom with your teacher sometime to learn this material. You have to be able to write an electron configuration. So, we have in our periodic table, we have organization by energy level, which is rows, blocks, which are orbitals, and then number of electrons are represented by the number of elements in that section of the periodic table. So all of them start with a 1s because this is the S block. Remembering we have moved helium right next to hydrogen. We just jumped it over here for electron configurations. So 1s is always the starting point for a full electron configuration. 1s. But the number of electrons in the 1s is the number of elements in that section of the periodic table. So row 1, S block, has 2 elements because, again, we've moved helium here, okay? So 1s2. Okay? If you don't remember this or have never learned it in the first place, I would strongly suggest going back to chapter 5 in the modules, finding the videos, email me. I have a video where I teach the full electron configurations and abbreviated electron configurations, and I can send it to you, okay? So tbreading@acsd1.org, send me an email and I will send you some video links, okay? But I'm just going to carry through and finish arsenic right now and not do it so slowly because we have learned this before, okay? But there's my 1s2. For arsenic, we're going to keep going, 2s2, 2p6. That carries through the second row. Arsenic's not until the fourth row, so we're going to keep going. 3s2, 3p6. I'm going to write it down here because I want to leave room for barium. Okay, 3s2, 3p6, 4s2, 4s2, and then we get to the Ds. Remember, Ds are a row below, or their energy level is one below their row number. So instead of 4d, this is 3d. There are 10 elements there, so 3d10. And then we get to 4p, and arsenic is the third one in, so 4p3. Now, abbreviated for arsenic. Abbreviated means you start with the previous noble gas. Well, arsenic's previous noble gas is argon. Remember, your noble gases are all right here, group 18. So argon, in brackets, no parentheses. Get rid of that, okay? Brackets, AR, okay? Square brackets. All right, then you finish the electron configuration. Everything that comes after argon to get to arsenic. So after argon, we have 4s2, 3d10, 4p3. 4s2, 3d10, 4p3. Okay? So there's the arsenic. I'm now going to do that for barium as well, and I'm going to go very quickly. If you want to follow along on the periodic table, you can do that with your finger, but I'm just going to go really quickly. I'm going to choose a green color here. Okay, barium. 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, 4p6. Okay. Still going because barium's way down here in row 6, so we're going all the way to 6. Okay. Keep going. 5s2, 4d10, 5p6, and then 6s2. So super long, longest one we'll ask you to do there, okay? Barium right here, its previous noble gas is xenon, so I'm going to put a little Xe in brackets and finish it with everything that comes after xenon to get to barium. Well, after xenon, we just have the 6s, and there's barium right there, so 6s2. Okay? All right, so that's number 1. We've done the first part of each element. Number 2 is determine the number of valence electrons. Determine the number of valence electrons. Well, it's the highest energy level. If I look even at just the abbreviated configuration, the highest energy level for arsenic is level 4, here and here. That's level 4, okay? There's 2 electrons here and 3 electrons here. So arsenic has 5 valence electrons, okay? 5 valence electrons. Barium's valence electrons are going to be in level 6. The highest energy level in its entire configuration is level 6. It has 2 electrons in that level, so 2 valence electrons. 2 valence electrons. Now, if you want a quick way to figure out valence electrons, you can look at the periodic table. Okay? Arsenic is right here. It is in group 15 or 5A. It has 5 valence electrons. So whatever the A group number is, that's the number of valence electrons. So 5 for arsenic. Okay? Barium is over here. It's in group 2A. So it has 2 valence electrons. Okay? Now this works for almost every element. The only one it doesn't work for is helium. 8A, helium only has 2 electrons. It has 2 valence electrons. But for the rest of them, if you look at their A group number, you're going to figure out their valence electrons. Okay? Now the transition metals are weird. We're going to get to those later. But right now, just group number with the A is going to be our number of valence electrons. Okay, third thing it asks you to do. Determine how many electrons will be gained or lost to give the atom an octet. Hint, close to 8 will gain the difference. Far from 8 will lose all valence electrons. Okay? So here, arsenic is close to 8. It's more than halfway to 8. It has 5. So it's going to gain the difference to get to 8. Okay? Please write the word gain when you're doing this. Gain 3 electrons. Okay? The reason you want to write the word gain is if you put a plus sign, that can get really confusing about charge and all of that. Okay, so gain 3 electrons, right? Over here, barium only has 2. Gaining 6 more is a lot of effort. Losing 2 is less effort, okay? And it's going to do that. It's going to lose 2, and I'm going to talk about why in just a minute, okay? If it's losing 2, which 2 is it losing? Well, it's losing these 2 right here, the outermost electrons. Those go away, and that leaves just the electron configuration of xenon. If I cover up that 6s2, now barium's highest energy level is level 5. It's here and here. It has 2 there plus 6 there is 8. So when you lose your outer valence shell, the one underneath is already full. It has 8. Okay, so that's why it makes it stable. All right, 4. Write the symbol and charge of the ion that will form when the electrons are gained or lost, and name the ion. Okay, well, arsenic, its symbol is As. You automatically start with the symbol of the element. Then we have to think about what kind of charge is it going to have if it's gained 3 electrons. Well, electrons have a negative charge. That's why that's in their symbol, E negative, okay? If you gain 3 negatives, you're becoming more negative by an amount of 3. So arsenic's charge is now 3 minus, As 3 minus. And that makes it an anion. And negative ions, we change the ending of their name to IDE. So this is arsenide. Arsenide. Negative ions get that "ide" ending. All right, over here, barium. Well, barium symbol is Ba, and it's losing 2 electrons. Losing 2 negatives is going to make it positive by a value of 2. So 2 plus. Barium 2 plus, okay? Ba 2 plus. And because it's a cation, it's positive cation, it does not change its name. It is a barium ion, okay? So you can write arsenide, you can write barium, you can write barium ion. That would be more clear, but technically its name is barium, okay? And then 5, write the full and abbreviated electron configurations for the ion formed. Okay, so arsenic. I'm gonna be lazy. You don't have permission to be lazy on your worksheet for the rest of these, but when it gains 3 electrons, we said it's gonna gain 3, what happens to the end of its configuration here is that it changes to 4p6, okay? So all of that would be my yada yada here, but you're gonna end with 4p6, okay? 4p6. Now if you look at the periodic table, 4p6 is going to take you all the way to krypton. So this is saying that arsenide, has the configuration of krypton. It is not becoming krypton because it still only has 33 protons, and protons make you who you are. Okay, 33 protons means arsenic, but it now has 36 electrons, so its configuration is the same as krypton, and that makes it stable. Okay. So abbreviated, I could do the same thing here. I could add 3 to my 4p and make it 4p6. But an easy way to do it, now that I've looked at the periodic table, it's gained 3. That gives it the same configuration as krypton. So the abbreviated for the ion is just Kr in brackets. So you could write Ar 4s2 310 4p6, that's fine. Or if you recognize that it's gaining the configuration of a noble gas, just write Kr in brackets, okay? For barium, it's losing 2 electrons, so a little different. It's losing these 2, so its electron configuration would stop at 5p6. So you would go, I'm going to yada yada it again because I have permission to cheat and shorten this. You don't have that permission, so make sure you write it all out. But it's going to go until 5p6. But it's abbreviated. If it loses those 2, this whole level goes away, and we're just left with Xe in brackets. And that's why it's losing 2, to get the configuration of a noble gas, the octet rule, okay? There's 10 more elements for you to practice with. I don't think any of them are as long as barium, but I might be lying to you. There's one that's as long as barium, but the rest of them are a lot shorter. So good luck. Email your teacher if you need help, and or talk to us in class. Thanks.